Okay. Okay, y'all. So we're going to go over free body diagrams. All a free body diagram is when we're looking at forces on an object, but we're freeing it from its environment. So this raft is going to be on water. There's going to be maybe rocks in the water. There's going to be maybe tree branches hanging. Who knows? There might be a person on the raft. We don't care. We're just doing a free body diagram of the raft. So we're freeing it of all the other stuff. When we get to the second part of physics, we might have to add forces and we're going to add forces. We're going to add numbers, have to do certain equations. We want to make sure we understand how to add the forces properly before we add the numbers. So basically, if I would just throw the forces and the numbers at you, sometimes it's a little bit overwhelming. So we're going to just practice adding forces this week. Okay. One of our initial steps to solving any problem is to draw a picture. A free body diagram, abbreviated FBD, is a picture used to solve problems involving forces. Now, this example is in my physics curriculum. This is going to throw new nomenclature and numbers out of us. We're just doing this for our notes. And then the next set of notes, this is my forces notes that I used to teach during IPC, when I really pushed my IPC kids to start learning physics nomenclature. So what we're going to do is we're going to do what's in the packet for one practice problem, put it all together, but then we're going to go back and we're just going to practice the most important forces that y'all will see in like college. Okay? So let's look at this raft example. A raft is free to move on the surface of the water. There is an upward buoyant force equal in magnitude to the force of gravity, 1,225 newtons downward. There is a force of 150 newtons eastward from a strong wind and 215 newtons east from the current. Draw the free body diagram for the raft, then find the force net, so the net forces, okay? Cross off end acceleration, we're not going to do that. And under the word net, I want you to write total. So all the word net means is total, just like in math class, we're looking at the sum or the total of everything. Okay, there were 4 forces they told us. Okay, first off, what I want you to do is put a central dot in the middle of the raft. Okay, when we removed this item from its surroundings, picture you being, or any item, being like a puppet, okay? And then that central dot is how you move that puppet forward or backwards. Do not do this. So I'm gonna draw something up here, don't draw it. If I drew a stick figure pushing that raft forward, okay, we're not gonna draw an arrow like this. Oh, we're pushing on the raft. Nope, from now on, okay, if we're pushing a raft and that raft pushing on its center of gravity is pushed in one direction, we're gonna say there's a forward force applied, okay? So we're no longer just drawing stuff going into it, we're just drawing where that center of balance is taking that thing, that object. Okay, so we have our center dot. Where are we gonna pull it? Okay. A raft is free to move along the surface of the water. There is okay, here's our first one. Upward buoyant force equal in magnitude to the force of gravity, 1,225 newtons downward. Okay, that was a lot. There is an upward buoyant force. So guys, we are gonna take our circle, our dot in the middle, and we are gonna apply an upward force to it. Okay. What is the letter for force? Capital F. Make sure it looks capital. Okay. Now, we need to specify that this is a buoyant force. What can we add as a subletter to make it buoyant? Speed. Good. F sub B. Some people want to be specific and write buoyant. That's fine too. but I'll know from the rest of the nomenclature in the letters, I know that that's the buoyant force. Okay, so equals, every vector quantity has a magnitude, a units, and a direction. What is the magnitude or the number for the buoyant force? There is an upward buoyant force equal in magnitude to the force of gravity, 1,225 newtons downward. Say it again.
1,225.
Good. Magnitude, units, bracket direction, upward. Okay. Equal in magnitude to the force of gravity. Okay, so this is where they're talking about a second force. 1,200 newtons downward. We all know gravity's downward. Perfect. So we go to the center, gravity pulls us downward. Capital F, force of gravity equals 1,225 newtons down. Okay, some people from the other classes says, what if we wrote downward? Okay, that's the same. What if they would have just did a D in the bracket? No, and this is why. Some people on the last quiz, if I would say southward, you could do a capital S for south. You could write south. You could write southward, but some people put SW for southward. What does SW mean? Southwest. Good. So remember, be specific when you're doing your directions. Okay. There is a force of 150 newtons east from strong winds. Okay, here's our third one. Okay, over here, just in case y'all forget directions, so we have our compass. North and south are super easy. East and west people forget. So remember, never eat, what do we never eat?
Sour worms.
Sour worms, soggy waffles, sour watermelon. I don't care what you use, just figure it out so that you don't confuse east and west. Okay, there is a force of 150 newtons eastward from the strong winds. Okay, what should we call this force? F sub W, I like it, for winds, equals 150 newtons east. And 215 newtons east from the current. So here's our fourth one. Okay, now y'all, there's already something taking up the space of eastward. That's fine, just put another one there. You can put it right behind it or you can put it right next to it, as long as I can tell it's in the eastward. So this one, the force, this one is the force of the current, so I'm gonna pick sub C, is 215 newtons eastward. Awesome. So by looking at this free body diagram, you can really hypothesize in what direction this raft is going to go. Now, we are going to learn in the later paragraphs is that when you get to some physics classes, not necessarily mine, the longer the arrow means the greater force. So really, which arrows on here should have the longest force based on their magnitude?
Up and down.
Perfect. The up is 1,200, the bottom is 1,200. These are only 200 and 100. So technically, if we were doing that, the greater the magnitude, the greater the arrows. Perfect. Anybody still copying? Okay. So let's move on. Okay, so follow with me. We then draw all forces acting upon the object using vectors pointing in the appropriate directions. For most questions, this will be up, down, left, and right. We generally choose to use the standard reference system where up is north, right is east, and these are positive, where left is west and down is south and are negative. So that's like if you moved it to a grid, like in math class, you have positive and negatives, okay? Notes. Only draw the forces that are acting upon the object. We do not include any forces the object is exerting on other objects, like the raft pushing the water. Okay, multiple forces in the same direction are drawn next to each other. If a force is acting down on an object, we draw this force below the shape. If it's up, it's above. If it's right, it's rightward. Okay. Force vectors always point away from the object. So if this was our raft, okay, if I'm drawing gravity downward, what they're saying is if you don't draw an arrowhead, you won't get that point. Some people get confused and they don't know whether to put the arrowhead this way or that way. That's incorrect. This is correct. Okay, so the arrowheads face away from the object. Last one, the length of force vectors are relative to their strength. That is, larger forces have longer vectors. Larger forces have longer vectors. So for example, something this long would be a force of the current, which is maybe 1,200 newtons east, versus something like this might only be the force of the current 250 newtons east. So the length depends on the magnitude. Okay, when you're done, flip it. That's how I know you're ready. When you're done, flip it. That's how I know you're ready. Okay.
No, I'm sorry.
Okay, I'm sorry. I will get you my notes. I'm sorry.
I said I was so ready.
You might have raised your hand, but I didn't hear you. I'm sorry. Okay, guys.
No, wait, I was writing the bottom part, like the very bottom part.
Landry, can you see yours? Okay, so this is the bottom, right? 250 newtons east. Okay. Okay, y'all. So everybody turn to this page. So force, F hat, is a push or pull causing motion, okay, with magnitude plus units plus direction. So it looks like direction. Okay, and here's an example here. Our magnitude is our number. Units are now always in newtons. Bracket, direction. We know this, okay? Now let's talk about the 5 most common forces. These are the only forces we're gonna deal with all week. These are the most common forces. I know that raft example gave you the buoyant force, the force of the wind, force of the current. We're just gonna talk about the 5 most common forces. Okay, the non-contact force that's acting through space, always on everything, is gravity. So that is F hat sub G. I do a lowercase g. Y'all, I've seen the subscripts, the smaller letters in both ways, but the thing you must have in all of these is a capital F for force, okay? And this is gravity. And y'all know it's always in what direction? Downward, okay? Here are the 5 forces that we have to determine if they're on something. Okay, the first one is applied. So this is F hat sub lowercase a. F hat sub lowercase a. This is called the applied force. And this is what's causing movement. So the applied force is the thing that's causing movement. If they did not tell you that there is something causing the movement, then do not put an applied force. So if something is falling, or just say dropped, it's not an applied force. So y'all look at, say if I had, we'll just say sticky hands or something, and I had the pen in my hand, and the pen dropped. Did I throw the pen down? Did I hit the pen down? It just dropped. So if it doesn't say it's caused by something, there's not an applied force. An engine applies a force. Your legs moving, apply a force, okay? Okay, if there's motion, there could be these 2 additional forces. F hat sub F, which is friction, and F hat sub AR, which is air resistance. Okay, and both of these oppose. What does the word oppose mean?
Act against.
Act against motion, oppose motion. Unless it says it's on ice, that's a frictionless surface, and that ball keeps on rolling across the ice, or that figure skater keeps on going across the ice, friction slows you down. Carpet has a lot of friction, okay? So when I'm walking across a surface, the friction is in the opposite direction. Also, air resistance. Some people are confused about directions of air resistance, y'all. Air resistance is opposite of motion. You know how you can tell? Your flyaways or your hair. If you're running fast forward, is your hair going forward too? It's going behind you. Okay, it's coming this way. Okay, because believe it or not, air resistance. Air is trillions of microscopic molecules of hydrogen, oxygen, nitrogen, CO2, all the things, and we're actually pushing through it on a microscopic level. Okay, if I jump upward, if my motion is upward, what direction is my hair, my flyaways? Downward. Okay, so air resistance is opposite motion. Okay? Last one, this is the newest one. This is going to be the hardest one for y'all to remember. This is called the normal force, F hat sub N. I do lowercase n, but I'm not going to lie, this one, depending on where my pen is, sometimes I accidentally do uppercase. But like I said, these lower cases, I try to keep them lowercase. If you would uppercase a sub, I'm not going to take off, but you must keep your force capital. Okay, and also I've seen the subs both ways. So this is normal. Okay, what is this normal force? Okay, where does gravity push us? Up or down? Why don't we just sink to the center of the earth, which gravity pulls us towards? What's underneath us?
Ground.
The ground. So when we push on the ground pushes back up at us. Also, if we were standing on a desk, we stand on a desk, the desk pushes back on us. So what the normal force is, it's the force that pushes upward so we do not fall into the ground. Okay? So this is upward force opposing ground. If you're in the air, will you have a normal force? No. Okay? What 2 forces go away when you leave the ground? Normal and friction. Good. Okay? So let's do a free body diagram of this car right here. First thing, draw your center. And what I'm going to do is I am going to just draw kind of this, kind of like those motion kind of little lines. And I'm going to tell you that this car is driving eastward, okay? So let's put all of the forces on this car that's going eastward. Okay, first off, is there applied force if the car is driving eastward? Yeah, the car is being pulled, got it, eastward. So our driving force causing motion is in the eastward direction. Okay, what two forces oppose motion? Friction and air resistance. Friction, it needs to be on the ground. Is this car on the ground? Yes. So ready? I go opposite direction, has to be directly opposite. So here is my force of friction because the tires are touching the ground. And here is my force of air resistance. This is always on anything that's moving. Okay, I'm going to add gravity. The force of gravity is on everything. Is there a normal force?
Yes.
Because it's on the
Ground.
perfect. So this would be a 5-point question on a quiz because it has 5 forces you have to add. I will always tell you the direction. Only way you would get points off is if you did not capitalize your F or you added it in a wonky way. Okay. Hey, y'all up here. Say if you wanted to add force, friction and force air resistance with 2 different arrows, and you added it like that. Don't do that, because that's actually giving it like a north component. Okay, so if you're adding 2 to the same direction, just back them up like we did. Okay. Anybody still copying? Okay. We got 2 more slides. Okay. Space Needle demo I will do when everybody's here. Okay, let's talk about net forces. Start off with an easy example. Okay, so net forces, under the word net, we're going to write total. Okay, so our free body diagram shows the net forces acting on one object. Okay, when we draw a free body diagram, I'm telling you there's only going to be 2. But what I usually do is I list all of them down the side and I go through all of them. Okay, so I'm going to start the ones that we learned in that order. So I'll do applied, friction, air resistance, normal, gravity. Okay, so the net force of a falling baseball. Okay, so keyword is falling, and we'll talk about falling versus, we're going to say hit or thrown. Okay, hit or thrown, they imply an applied force. You apply your force to a ball to throw it. You apply a force with the bat to hit it. Falling, there is no force applied.
Like gravity.
It's the same as no force applied. There's forces, but there is no applied force. Okay, so because it's falling, no applied force. Okay, friction. Friction and air resistance have to do with moving things. Friction, the ball has to touch something. Is there friction? No. Is there air resistance?
Yeah.
What direction?
Down. You're up.
Opposite motion. Good. So if the motion is down, air resistance is up. So we have force, air resistance, and just in parentheses to remind y'all, opposite motion. So it opposes motion, it's the opposite. Normal, is it touching the ground? No. And gravity, everything is gravity. What direction? Downward. F hat sub G. So how many points would this be worth on a quiz? 2 points. Okay, if you added an extra one, I would take that off. Okay. Okay. Everybody take a look at the next slide. Take a look at the next slide. Okay, I talked to you about two objects, a runner and a ball that was just hit. Now, if I told you it was hit, that is an applied force. A force was applied to the ball to make it move, okay? So, now the only thing, I didn't specify direction, so I'm gonna do that now. Draw a free body diagram for a baseball that was just hit. I want you to put, so it was just hit northeast. That's why I have the little motion lines, northeast. Hit by the batter, and for a batter who is running, he is going to be running eastward. Okay, draw your center dots, and at your seat, I want you to work on these. I'll come around and we'll solve this in like 3 minutes, and that's where we will stop today. So these are the last things we need to do today. Put our forces on this. I'll list all the forces here so y'all could look at them. So we have force, applied, force, friction, force, air resistance, force, normal, force, gravity. If you want me to check them, I could check them and we'll go over them on the board. The ball is hit northeast, the runner is running east. Okay, so y'all, I'm not gonna lie, first thing I always do is put gravity on everything because that is a point that everybody's gonna get because everything needs gravity. That runner is gonna need the force of gravity, and that ball, no matter what, is gonna need that force of gravity. That runner is just like that car we did. He is running on the ground, so he'll have all 5 forces. Okay, he is causing himself to go forward for the push or pull, so he is applying his force applied forward. Okay, when you are moving, 2 things can oppose you: friction and air resistance. He is touching the ground, so he definitely has friction on the ground, and he is moving, so he will have air resistance. He's on the ground, so he's got gravity, but then the normal force opposes him. This is worth 5 points. He's got all 5. What if he was jumping midair? You would take away normal, you would take away friction. Good. What if he came to a stop? What would he only have if he were stopped on the ground? Normal and gravity. Good. Okay, so this ball was hit northeast. Yes, northeast. You must put it in the northeast direction. Okay, so my force applied is in the northeast direction, and Air resistance is directly opposite. So it must be exactly air resistance. 3-point question. Y'all have any questions? We're going to go over 10 questions tomorrow, and then y'all will have your quiz. I was going to make the quiz on Wednesday anyway, but I know a lot of people are gone for the Santa stuff tomorrow. So our test is Thursday, unless you would want to take it Wednesday. Okay?